Yes, sir, it's audible.
Thank you. Then we discussed in the last class, I think block 2, 12th unit, maybe. Yeah. So now we'll discuss in that block last unit, then back to again we'll start first unit concepts. 1 second. If it is there, your material once open last 13th unit, block 2, 13th unit. Operational amplifier waveform generator. Operational amplifier waveform generator. 13th unit. Paper 4th electronics paper. Block 2 unit 13. Operational amplifier. Operational amplifier waveform generator. Yes. Operational amplifier waveform generator. The operational amplifier under open loop condition, closed loop condition we discussed in the previous chapters, the previous units. Now we'll see the output values and CRO in the wave formation. That wave generator part we'll discuss it now. Okay. Usually, one of its saturated state in operational amplifier, small differential input signal, and proper polarity utilized to switch off on mode in operational amplifier. This switching property is used in operational amplifier. Yes, operational amplifier components. In that, we'll take it as sine wave generator first, then converted sine to square wave or any other formation. First, we are taking here sine wave generator. Sine wave generator. You can take connection operation amplifier plus minus. And here inverting pin, non-inverting pin. Non-inverting pin connected to resistance and capacitors are in series to the bypass. Bypass again, this is connected to again ground, which is connected to bypass resistors R1, R2. This R2 is can take it as feedback resistance. Instead of R2, you can take it as feedback resistance. And these two connectedly common connection. This is the output terminal V out. Again, here the splitting thing is this part is a operational amplifier part. And additionally, we can take one resistor and capacitors are connected in parallel. Terminals connected to the ground. This part is a feedback part. This part is feedback part. This upper part is a operational amplifier part. Amplifier. Okay. Right. It can look like one Wheatstone beach type only. One, two, three, four components. These four are arranged in a bridge manner with operational amplifier. I think you know Wheatstone beach. Four resistors or four capacitors are connected in a bridge manner like these symbols. Such component is called as a Wheatstone bridge. So in that same thing, this is a one component, second, this is a third, this is the fourth one. We can take like that only equivalent circuit diagram in a bridge manner. This is a one resistor, this is a another resistor. One second. Here, these components again connected in the parallel resistor and capacitor part. Again here, this is also resistor, it's also capacitor. Here two capacitors, two resistors. Hai. One thing is in series, other one in the parallel. So series resistor and here capacitors. And now this amplifier you can take it as in the middle. This amplifier you can take it as in the middle. One thing is negative, this is a positive, and these terminals connected to the junctions. One junction here, other junction will be here. Again, give the ground connection. Like here P, Q, R, S type. Here first resistor R1, feedback resistance RF, then RC, here also RC. That equivalent circuit diagram in the bridge manner. Okay. No? Entire these two affected one impedance value. These two affected impedance value. Here one resistor, this is nothing but P, this is Q, this affected value is R, this affected value is S. P, Q, R, S. Like that. Now we can observe. And CRO, nothing but oscillator. And CRO, oscillator, circuit in which balanced bridge, bridge and bridge type, bridge is used as a feedback network is the like a Wheatstone bridge oscillator. That is a right side diagram is a Wheatstone bridge oscillator. The bridge is clearly indicated. The bridge has a series RC network in one of arm parallel resistor and capacitor. One of arm is series resistor and capacitor. One of arm is a parallel condition resistor and capacitor. Other arm is a series combination resistor and capacitor. Okay. And one of arm is a resistors R1 RF. This entire thing is a connected in the bridge manner. Okay. Right. That parallel affected impedance. Resistor and this capacitor affected impedance, I can feel it as a Z1. This is I can feel it as a Z2. Like R1, R2, R3, R4 type. Or else PQ, RS. 4 ohm resistors. That affected values thing. Okay. The phase angle criteria of oscillation amplifier. Oh, when already we know in the previous block, first block, phase shift oscillator. RC coupled amplifier conditions. There, frequency of RC coupled amplifier with a component of resistor and capacitor. That one frequency is equal to 1 by 2 pi sorry, 1 by 2 pi RC. LC condition different for in, sorry. Frequency of RC coupled, R and C coupled components formula 1 by 2 pi RC. We know in the previous chapters only. Frequency of LC oscillation, that is a F is equal to 1 by 2 pi under root of LC. This is a LC oscillator, this is a RC oscillator. We are using RC oscillator now, so we have to use this frequency formula. Frequency of RC coupled oscillator F is equal to 1 by 2 pi RC. 1 by 2 pi RC. If the actual frequency is equal to resonant frequency, in that condition you can take it as F naught. The maximum frequency, but resonance frequency condition. The oscillation frequency or resonant frequency R naught is equal to 1 by 2 pi RC. Okay. This is a frequency condition. Again here current gain, voltage gain, that is a components things only, same thing. So finally we'll get the wave formation of these sine wave generator in the output on the CRO, cathode ray oscillator. Then waveform will be get in that like this, in the sine wave like this. This is a propagation line that will be get sine wave curve. In the output in the CRO of operation amplifier sine wave generator. So finally the wave will be get in the functions sine waveforms. Okay. This sine wave, it can modified into square wave. The sine wave, it can modified into square wave. Then instead of these components, modified circuit diagram we have to use R1, R2, R3, R4 is there now. So in that purpose, you can use 4 components only. So this sine wave converted into square wave purpose. So modify the circuit diagram. Here R as stays, instead of capacitor, you can take one more resistor. This feedback resistor as stays. Only in input resistance place, you can take capacitor. Input capacitor place, you can take input resistance place, you can take capacitor. The sine wave, it can convert it into square wave. Sine wave, it can convert it into square wave. Then we have to observe voltage across the each component. Voltage across the each component conditions. V1 is equal to R1 by R1 plus R2 into input voltage. V2 is equal to R1 by R1 plus R2 into positive saturated voltage. The two voltages, applied voltages, then the sine wave, it can convert it into square wave. Sine wave, it can convert it into square wave. If you want to change that square wave converted into triangular wave, like ramp type, in that condition also, we can modify the circuit diagram. Amplifier, 2 stages. Nothing but the 2 amplifiers we have to use. For the 2 amplifier conditions, input resistance and feedback resistance. It can split in the 2 branches. In the one branch, one feedback resistance place, you can take capacitor. Another one you can take it as resistance. Then the square wave, it can convert it into triangular shape wave. Nothing but triangular wave. Triangular wave only. Okay, na? The 2 already there in your material, page number 182. triangular wave diagram, and square wave diagram. Just you can go through diagram and wave formation. Okay, na? Right. So here only enough this unit. Now back to first block. I'm not expecting from this unit some most maximum questions in examination point of view. If we get, we can leave it in the choice. But because it is little bit easy to remembering is not possible. So that's why I'm my suggestion you can leave this unit in the choice. Better. Less strain. Okay. Now back to first unit. Yeah. Is it clear? Now I'm coming back to again first unit. In that unit, again we'll start first onwards. Is it okay? In the offline mode, only few students are followed these units. Na? So now we can go through it. First unit, it is easy. This is the intermediate and degree standard levels on. Paper 4 electronics block 1. Now again you can go through it unit 1 onwards. Unit 1. This is nothing but a semiconductor diodes. Semiconductor diodes. Okay. Basic thing. Materials are classified into three categories based on their charge flow. Number one is conductors, number two, insulators, number three, semiconductors. The materials allow through them charge easily, that is known as a conductors. Material does not allow through them charge easily, that is called as a insulators. Partially allows through them charge, that is called as a partially block one. Yeah. Obviously, black one comparing with the black two, more topics but easier than black two. Black two kanna black one topics easy ఉంటాయి. Someone sent message here, okay na? Lahari, yeah. Comparing with the black two, black one concepts units also more, but easier than black two. That's why I'm preferring black one on. Okay, right. Here, semiconductors. Block two is total something. Yeah. Yes. Black two totally operation amplifier only. Right. Okay na? Come back here. Semiconductor. Semiconductor devices, semiconductor materials. These are the partially allows through them charge. For example, silicon, germanium, these are the semiconductor materials. These are the fourth group elements. Okay. A best example of semiconductor devices material is silicon, germanium. Yeah. In that semiconductor devices, first basic thing is a PN junction diode parts. Before that, energy bands also there, valency band, conduction band theories. But that is not there in our syllabus. That is the basic point all. Now we can take it as basic concept in the PN junction diode. The sandwiching of P-type and N-type semiconductor material suitably. That is called as a semi PN junction diode. One second. Hello. Hello. Okay. Okay. వచ్చాక నాకు కాల్ చేయండి. టైం ఫాలో అలాగే. Yeah. Semiconductor material means when P-type and N-type semiconductor materials are suitably doped with each other, then PN junction diodes are formed. In the simplest way, the sandwiching of P-type, N-type material, like burger, sandwiching, joining, pair, that is called as a sandwiching, burgering. P-type material, N-type. P indicates basically is a positive, N indicates basically is a negative. These two are joining here like this. This is a P, this is a N. Either capital N or small n, your wish. P represent positive charge carrier ions, that nothing but holes. N represent negative charge carrier ions, electrons. The sandwiching here. When these two are sandwiching each other, the junction is formed. The junction is called as a PN junction diode. Between the across the junction, one layer is formed. That layer is called as a depletion layer. I think you know this layer is called as a depletion layer. Depletion layer. When these two materials are connected to battery terminals respectively, plus or minus. Okay, here current measuring purpose milliampere or microampere. When battery terminals are connected here, these PN junction diode or PN junction materials, it can work. So PN junction diode, it can work in the two bias system. One is a forward bias, other one is a reverse bias. Second one, reverse bias. RB, reverse bias. FB, forward bias. Okay. What is meaning of forward bias? What is meaning of reverse bias? In the simplest way, when battery positive terminal connected to P region, P indicates positive, this battery are positive, also positive connection, negative connection, that is called as simplest way, you can say forward bias. When battery negative terminal connected to P region, for example, it is you can feel this is a forward bias. This is a PN junction diode. This is a P-type material, N-type material. P indicates positive, N indicates negative charge carrier ions. This is connected to the battery. These are the connected to the battery. A current measuring meter is a microampere. Is in the reverse bias, or simply you can say ampere also. Okay. When the battery positive terminal connected to N region, battery negative terminal connected to P region, that is called as a simply you can say the reverse bias. Again, this layer is called as a depletion layer. This PN junction diode, it can work in two bias. Now, one is a forward, other one is a reverse. First, we'll go through it forward bias stories. In the forward bias, battery positive terminal connected to P region, a negative terminal connected to N region. Okay. Due to these positive terminals, that positive charge carrier ions, it can move towards the depletion layers. Due to this negative, obviously we know repulsion, negative charge carrier ions, it can move towards the depletion layers. Oh, holes moving towards depletion layer, electrons which can move in depletion layer, na, the finally depletion layer width decreases. Depletion layer width decreases. In forward bias, depletion layer width decreases. If the depletion layer width decreases means diffusion, drifting of holes from P region to N region and diffusion of electrons from N region to P region, it can easily drift diffusion. అంటే రీప్లేస్మెంట్ ఇక్కడ నుంచి హోల్ అక్కడ షిఫ్ట్ అవుతుంది, అక్కడ ఉన్న ఎలక్ట్రాన్ ఇక్కడ షిఫ్ట్ అవుతుంది, పేరింగ్. సో డ్రిఫ్ట్ ఆఫ్ హోల్స్ ఫ్రమ్ పి రీజన్ టు ఎన్ రీజన్ అండ్ డిఫ్యూజన్ ఆఫ్ ఎలక్ట్రాన్ ఫ్రమ్ ఎన్ రీజన్ టు పి రీజన్, ఇట్ కెన్ బి ఈజీలీ. Okay, that movement of charge particle from one region to another region will be easy. Then the moment of charge particle against the electron flow, electrons it can move towards the negative charge plate to positive charge. Na? So in this from this side to electron it can flow in this direction. Electron flow opposite direction current flow in the conductor. Understood? From negative terminal plate to electrons, it can move towards the positive plate. Against electron flow direction, a current it can flow in a conductor. Positive region to negative region, it can flow current in a conductor. When external voltage applied to the junction, when external voltage applied to the junction, the direction that cancel the potential barrier. Oh, what is potential barrier? Potential barrier here. Potential barrier. This layer is called as a depletion layer. The potential difference between the depletion layer ends, that is called as a potential barrier. Potential barrier. అంటే ఇక్కడ ఉన్న పొటెన్షియల్ అంటే మనం ఎక్స్టర్నల్ ఎలక్ట్రిక్ ఫీల్డ్ ఇస్తే దీన్ని క్రాస్ చేసి ముందుకెళ్తాం. That level only we have to give the external voltage across the battery. Then only electron it can diffuse from N region to P region. Okay. Then current flow from positive terminal to negative terminal, or else positive is P region to N region in the direction current it can flow. Okay. No? Means basic thing is a hole's flow direction is called as a here hole nothing but positive charge carrier ions. Negative is a electrons. This hole's flow direction, it can say the current flow direction. Then finally depletion layer width decreases, that mobility of the electron and holes possibility is more than maximum current flow in a forward bias. So that current measure in forward bias milliampere. Maximum current flow compared with the reverse bias. So this is the thing. So this one, we have to express the voltage versus current graph. For example, if I took voltage on x-axis, current on y-axis, current measure in terms of milliampere, voltage measure in terms of volt. Then up to certain applied voltage, no changes in the ammeter reading. After certain applied voltage, up to certain voltage, no changes in the current, means almost zero. Up to certain applied voltage, here 0, for example 2 volt, 4 volt, 6, 8, 10 and so on. Up to certain voltage, applied voltage, no changes in the voltage. After that only it can gradually exponentially increases. This is in the forward bias. This is in the forward bias. VI characteristic graph in forward bias. Now come to the story about the reverse bias. Simply terminals are reverse battery, otherwise you can flip the this semiconductor materials. When you are flipping here battery terminals, then here reverse connection, then depletion layer. Due to this negative and positive holes, it can attract towards the negative terminal plates only, or to holes it can repelled by the depletion layer, and electrons also it can repelled by the depletion layer. Then finally depletion layer width here increases. In the reverse bias, depletion layer width increases. Only energetic electrons it can diffuse from n region to p region. Then to holes it can drift from p region to n region. Only energetic electrons only it can jumping from one region to another region. When you are giving external electric field applying across the battery terminal, due to that external electric field, that is a lesser than the potential barrier. That's why it won't move maximum number of electrons from one region to another region, n region to p region. Less number of electrons it can jumping from one region to another region means, n region to p region means, less amount of current flow in a circuit. That current measure in terms of microampere. That current measure in terms of microampere. Again, current flow, battery positive terminal to negative terminal only current. It can flow in the reverse bias. The forward loss and the reverse loss. Again, we have to take the VI characteristic graph. Again, I'm taking reverse bias, na negative voltage will apply, -2, -4, -6. Na. That value I'm taking here in the volt on x-axis, current value I'm taking on negative y-axis. Then current measure here in the reverse bias is a microampere, like this. Graph nature will get up to certain applied input voltage. Again, here also no changes. After that, exponentially decreases. They're exponentially expanded, here exponentially decreases in the reverse bias. In this one, at what particular applied voltage voltage value exponentially increases? My bad. At what applied input voltage current value exponentially increases? For that corresponding voltage is called as a knee voltage. In the reverse bias, at what particular applied input voltage current value exponentially decreases? That value is a avalanche breakdown voltage or avalanche voltage. Avalanche breakdown voltage. Avalanche breakdown voltage. Or simply can say the avalanche voltage also in the negative regions, in the negative region. Okay, these graphs are explanation theory important. You can expect in the 10 marks, maybe they will ask, what is PN junction diode? Explain PN junction diode working in forward bias and reverse bias along with IV characteristics graph. Then we have to write statement of PN junction diode, and we have to explain the working of a PN junction diode in the forward bias and reverse bias along with the circuit diagram and graph. Is it clear? Yeah. Hopefully, I'm feeling this is a okay for yourself, everyone. Then next we can go to applications of diodes. PN junction diode applications. We have to see now. Applications of PN junction diodes. Okay, now. First order this thing, then we'll start terminating. Applications of PN junction diode. Note down. Applications of PN junction diode. Number one is rectifier. Yeah. Applications of PN junction diode. Number one is rectifier. Number two, Zener diode. Number three, photodiode. Number four, LED. Number five, solar cell. Number six, varicap diode or varactor diode. ఈ అప్లికేషన్స్ లో ఏదో ఒకటి అడగొచ్చు. ఓకేనా? సో థింగ్ ఈజ్ ఫస్ట్ వన్ ఈజ్ what we can say, applications of diodes, or else you can say the types of diodes also. PN junction diode used as a some of the things, na. Applications of diodes are now okay, then types of diodes are good. Okay, types of diodes and దీంట్లో rectifier రాదు types of diodes లో. application లో rectifiers వస్తాయి. అంటే PN junction diode used as a some other parts లాగా. In this one, first thing is a photodiode. ఏ ఆర్డర్ రాసుకోవచ్చు, ఇది ఆర్డర్ ఏం లేదు, ఫిక్స్ అనేది. ఎల్ఈడి, light emitting diode. Next one, solar cell. Next one, varicap, VARY, varicap diode or varactor diode. Varicap or varactor. ఇది బాగా రిపీట్ చేస్తున్నాడు. varactor diode, photodiode, LED, solar cell. Next one, Zener diode. ఈ 5 నుంచి ఒకటి ఎక్స్పెక్ట్ చేయొచ్చు 5 మార్క్స్ లో. ప్రీవియస్ వన్ పిఎన్ జంక్షన్ డయోడ్ వర్కింగ్ కండిషన్ యూ కెన్ ఎక్స్పెక్ట్ ఇన్ ద 10 మార్క్స్. ఈ 5 లో ఏదో ఒకటి 5 మార్క్స్ ఎక్స్పెక్ట్ చేయొచ్చు. సో ఫస్ట్ థింగ్ ఈజ్ ఎ photodiode. Simply you can say photodiode is a application of PN junction diode. Photodiode is a application of PN junction diode. This a photodiode is essentially, it can works in reverse bias. Application of PN junction diode 1 point అనొచ్చు. It can works in the reverse bias అని చెప్పొచ్చు. Essentially it can works in the reverse bias. Okay. A reversed PN junction diode has been reverse saturation current. If light is allowed to fall on such a reverse bias of PN junction diode, additionally electrons it can generated in both P and N regions. For example, we'll see diagram. Sir, this is a, we know in the previous condition, P-type, N-type materials are doping or sandwiching. Here is a positive type, negative charge carriers. Oh, what they said, it is working in reverse bias, like this. It is a reverse bias on. Now, what is saying here, light particle or quantum particle, light is allowed to fall on depletion layer. E is equal to h nu na. According to quantum theory, light is a bundle of energy pockets. E is equal to h nu, quantum particle. E equal to h nu. In terms of wavelength, you can written as E equal to hc by lambda also. All right. When it is connecting like this, here ఇక్కడ ఉన్న ఎలక్ట్రాన్స్ ల కన్నా ఇక్కడ మళ్ళీ లైట్ పార్టికల్ అనేది ఇన్సిడెంట్ అవుతుంది కాబట్టి నెగటివ్ చార్జ్ పార్టికల్ ఇక్కడ ఇంక్రీజ్ అవుతాయి, ఇక్కడ యాక్సెస్ అయిపోతున్నాయి కదా. Pairing. That thing is saying, if the light is allowed to fall on such a reverse biased PN junction diode, additional electron hole pairs are generated in depletion layer due to that incident radiation. It produces a very large change in minority charge carrier concentration and hence increases the reverse current through the diode. అంటే రివర్స్ బయాస్ లో కరెంట్ ఫ్లో ఫర్ ఎగ్జాంపుల్ 5 మైక్రో ఆంపియర్ అవుతుంటే అడిషనల్ గా సర్టెన్ ఎనర్జీ ఇన్సిడెంట్ అనే డిప్లేషన్ లేయర్ అవుతున్నప్పుడు ఎలక్ట్రాన్ హోల్ ఫెయిర్ ఇంక్రీజ్ అవుతున్నాయి, దానివల్ల కరెంట్ స్ట్రెంత్ ఇంక్రీజ్ అవుతుంది. ఇన్స్టెడ్ ఆఫ్ 5 లో మోర్ దెన్ ఆఫ్ 5 కరెంట్ ఇంక్రీజ్ అవుతుంది. రివర్స్ బయాస్ కరెంట్ increases. It is found that the current through the diode varies almost linearly. కంటిన్యూగా కరెంట్ బ్రేక్ అవ్వకుండా ఎక్స్ట్రా లైట్ ఇన్సిడెంట్ అవుతుంది కదా, కంటిన్యూస్ గా లీనియర్ కరెంట్ ఇట్ కెన్ ఫ్లోస్ ఇన్ ద ఫార్మ్ ఆఫ్ ఏ లైట్ ఫ్లక్స్. అంటే బంచ్ ఆఫ్ లైట్ ఇన్సిడెంటింగ్ అంటే continuously incident on the depletion layer, it can sending electron hole pairs to the depletion layers. In that one additionally it can flows. Hence light can be detected with the light flux. Hence light can be detected using a reverse bias PN junction diode is known as a photodiode. Is known as a photodiode. This photodiode is kept under the dark condition and sufficient reverse voltage is applied. Then an almost constant current continuously it can flows in a conductor. That current is proportional to the minority charge carriers from N region to P region. The majority charge carriers are not allowed to across the junction. Only minority charge carriers it can allow. In the reverse bias, minority charge carriers are electrons only. In the forward bias, majority in the P region, positive charge carriers are majority charge carriers. In the N region, majority charge carriers are electrons. So this PN junction diode additionally, in the previous condition is current, total current I is equal to IE plus drift current ID type. The total current I is equal to IE plus ID. Okay. That is a thing. Then here, PN junction, my bad, photodiode. The photodiode circuit symbol. I think we know in the previous condition, PN junction diode circuit symbol. This is a PN junction diode circuit symbol. This is a P region, which is a N region. PN junction diode circuit symbol. Now here, photodiode circuit symbol. First, we can draw PN junction. This is a P region, N region, light ray incident on the surface. Sometimes they can use circle also. Light incident అయితేనేమో photodiode, light emit అయితేనేమో దీని రివర్స్ గా వస్తుంది నెక్స్ట్ అది LED. That is a circuit symbol of photodiode. Now you can draw the IV graph, voltage versus current characteristics graph. It can works in the reverse bias. So this voltage here, current will be here, current in terms of milliampere, here current in terms of microampere. Then here voltage is V. Now it can works in the reverse bias now like this. Here dark region, then it goes on intensity increases. Goes on intensity increases. Okay na? In few books they can give this one, it can give in first coordinate also. But generally I'll consider here the forward, here is the reverse na easiest way. That's why written as here. Or else you can turn this graph to express like this also. But you have to take the proper labeling. Current in measure in terms of microampere. Why? Because it works in the reverse bias now. So it is a I in terms of microampere. So voltage in terms of volt. Is it okay? Not done. And uses of photodiode. Generally, you can use in the barcode scanner purpose or barcode scanner data, QR code detection purpose. Based on example in the shopping malls, and it can use photodiode can turn its current on-off mode in nanoseconds. A photodiode is used to light detection purpose. Photodiode it can find the tremendous applications in optical communication systems, etc. Okay, now next at the same time only you can learn another one is a LED, light emitting diode. Light emitting diode. LED, light emitting diode. It is also a special special type of diode of PN junction diode application, but it can works in forward bias. Photodiode it can works in the reverse bias, but LED it can works in the forward bias. Same story. Here light incident in LED light emitted. That light emitting na it can extracted out. Best example LED bulb. So here you can change the terminals. P region connected to positive terminal of the battery. N region connected to battery negative terminal. Here current measure in terms of milliampere. Forward bias na milli, reverse bias micro. So a circuit symbol for LED light emitted out. Arrows outward unte LED, arrows inward unte photodiode. Then current same thing only. Then graph. It can get in the forward bias means first quadrant in my way. So we'll be get like these different colors, VGR colors. Current value here in terms of milliampere, here in the voltage in terms of volt. That is a IV characteristics of LED. Uses of LED again, it is also used in switch on off mode switching. And next LED is the cheapest, and it can use in the light fast on off switching purpose light. So many things will. And maybe sometime they can express here wavelength relation formula also. E is equal to h nu na. So from that they'll ask maybe frequency of light or wavelength of light. So it can be written as E is equal to hc by lambda. Hc value constant only. Then we'll get here electron in terms of electron volt, energy in terms of electron volt. When you're considering this is part over na. Then you can take it as E. H value Planck constant, I think you know 6.625 into 10 to the power of minus 34 joule second. C, speed of light in vacuum, that is a 3 into 10 to the power of 8 meter per second. Lambda, we can take it as in terms of angstrom. Then E value will get in electron volt. After substitution, these values will get some constant value, that is 12,400 by lambda value can take in terms of angstroms. Then finally we'll get energy in terms of electron volt. If you want to find out wavelength, then you can take from this only. Lambda is equal to something by something. So lambda is equal to 12,400 by E value. E you can take in terms of electron volt. Then lambda value will get finally in terms of angstroms. Or else it can convert it into electron volt to some other joules. So 1 electron volt value 1.6 into 10 to the power of minus 19 joule, or else 1 joule is equal to 1 by 1.6 into 10 to the power of minus 19 electron volt. Maybe based on this thing, very rare cases, they will ask the numerical problem for 5 marks. Based on this thing on. But very rare cases. Give me 1 second time, I'll take one glass of water. Note down. Yes. Next one is a solar cell. Next application you can take it as solar cell. Solar cell or solar panel, solar battery. It is a basically application of PN junction diode, which can convert light energy into electrical energy. Solar cell. The sunlight it can convert into electrical energy now. Solar cell, it is a device which can convert light energy into electrical energy. It is also called as a solar energy converter. It is application of PN junction diode. Okay, na? Again, construction of solar cell panel, solar cell or solar panels are solar batteries. And P-type material, N-type materials. P is nothing but positive terminals. N is nothing but negative terminal of a batteries. A solar cell consists of PN junction diode generally made of semiconductor materials, silicon or germanium. It may also be constructed with many other semiconductor materials like gallium arsenide, indium arsenide, or cadmium arsenide, like etc. The PN junction diode so formed is packed in a with glass window on top so that the light may fall upon P and N type semiconductor materials. The thickness of the P region is kept very small so that electrons generated in this region can be diffused to the junction before the recombination takes place from N region. This is a connection of the construction of the solar cell. Understanding? Once go through it better your material page number 9. Someone, sorry, I didn't see no message. Okay. Someone said Akshita, next class the fourth block explain cheyandi. Okay, I will try. Next, someone Devadas from Nizamabad. Board is not clear. Oh my God. Now you can observe, dear students, visibility of this board. Is it okay? Any problems in the visibility? Hello, DS. Right now is okay. Thank you, sir. Devadas teacher from Nizamabad. Okay. 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 Thank you, Lahari ma'am. Like this, any technical issue, you can immediately message. Okay. Then I'll adjust board visibility and volume or video or any audio, any other things. Okay. Na? Right. Now come to the explanation part about the solar cell. In your book, page number 9. Okay. Na? That construction part easy only. Now we can go through it. Working of solar cell or solar panel diagram. Here P-type, N-type material, now we are sandwiching one upon other. In the previous condition, we consider as a adjacent sidely, but now we are taking one upon other. N region here bottom, P region here is a top position. Okay. Means the sunlight exactly incident on the P region surface. In the previous condition, the sunlight incident in the depletion layers in the photodiode or LED condition. But right now we are adjusting that instant sunlight exactly on the p region of p-n junction things. Upon it, they are arranging one glass plate. డైరెక్ట్లీ మెటీరియల్ మీద పడకుండా గ్లాస్ పైన పడి గ్లాస్ నుంచి ట్రాన్స్పరెంట్ అయ్యి మెటీరియల్ మీద ఇన్సెంట్ అవుతుంది. ఓకే, దట్ ఈస్ థింగ్. అండ్ ఇన్ దట్ ఇంటర్నల్లీ మెటల్ రింగ్స్ ఆర్ దే ఆర్ అరేంజింగ్ లైక్ metal rings. In this ring only electron proton pair it can form, that it can shifted into the n region like this, and the bottom position, but the collection of that pairs will be here, bottom collection. Again it is connected to the output, means our input, external agent. This is a positive terminal, this is a p now, positive terminal connection here to the resistance part, and here negative thing is connected here. ఆ వైర్ని బెండ్ చేసాడు అంతే, అదే అవసరం లేదు. ఓకేనా? దిస్ ఇస్ a current flow direction I, positive to negative only. This is a load resistance across this thing will consider as a output. Here is a input. Input is a light energy, output is a electrical current. That electrical current we are taking as a in the storaging of batteries out connection. Right? Now you can observe the story. When light ray or when light is allowed to fall or allowed to incident on PN junction diode in the top of the P region. This is a PN junction diode in the top of the top surface of the P region, it crossing across the glass slab. Photons collide with valuable electrons and impact them sufficient energy, enabling them to leave the parent atoms. That instant negative charge particle, light ray instant on the P region top surface, that it passing through the glass slab and it can collide with the protons. That protons collide with the electrons, means like proton electron pair it can form. That proton electron pair it can move towards the n region type. The generated both in the p region and n region electron proton pair it can move towards the n region side. That is shown in the figure. These electrons and holes reach the depletion layer or depletion region towards the window side by diffusion, by the diffusion pairs type on. Okay. By the strong potential barrier or external existing electric field, it can move slowly towards the n region side on. There follow the construction the minority current, which is directly proportional to the illumination and also depends on the surface area of the incident light. అంటే ఎంత సర్ఫేస్ ఏరియాలో ఎన్ని ఎలక్ట్రాన్స్ లైట్ పార్టికల్ గా ఇన్సిడెంట్ అవుతా అన్ని పేర్స్ గా ఫామ్ అవుతుంది ఇంటర్నల్లీగా in the p region and n region. That p and n region, the electron hole pairs it can form, that electron hole pairs can move towards the battery type, like output terminal side. The accumulation of electrons and holes on the two sides of the junction, this follows the junction na. The accumulation of electrons and holes on the two sides of junction gives rise the open circuit voltage, that is called as VOC, open circuit voltage, VOC. The accumulation of electron and holes on the two sides of the junction gives rise an open circuit voltage, which is a function of illumination. The open circuit voltage produced for a silicon solar cell, that is nearly silicon diode voltage is a zero point 0.6 or 0.7 voltage. Germanium 0.3 or 0.4 voltage, the terminal voltage value. And the short circuit current, short circuit current, short circuit current, ISC, short circuit current. This is a symbol, short circuit current. And this is a open loop voltage, open circuit voltage, open circuit voltage. Now we have to take that based on that values only we graph nature on furtherly. Power consumption about that VI conditions 15 percentage obtained with thin N region diffuse layer into the P only, pair only, means P region. Solar panels providing 5 watts at 12 volt have been built operate 24 hours a day by reaching the batteries during daylight hours. In the daytime, the light it can absorb, and the P region that is slowly injected to the depletion layers of the PN junction, that slowly it can sending the pair of combination or pair of electron holes slowly towards the N region side. It can goes on 24 hours. Once the light incident on the surface, that first it can consumption lot of amount of energy from the sunlight. That is nothing but light energy. That is a H nu. Incident on this, again slowly it can injected to the N region type, that is converted light energy into electrical energy. Light energy into electrical energy. Now we can go through it here. VI characteristics of solar cell. VI characteristics of solar cell. Then it goes on like this. The graph nature is like this. Here current value, here voltage value, here again here negative voltage, here current. That will be get graph nature like this. Here open circuit voltage VOC. VOC. Here is a short circuit current. That is a ISC. ISC VOC. That graph is not there in your material, but he given different way. Lecture, can different way lecture. All the graphs in your material he explained in first coordinate only, but I was written in the different coordinates. Na? Negative not negative, forward not forward condition. Is it okay? Note down. Okay, the next one we'll see. First one is a, what you can say, the photodiode. Second one is a LED. Third one we took it as solar cell. Then we can take it as next one is a varicap diode or varactor diode. The next one is a xenon diode. First we'll take a Xeno diode, then we can go for varicap. Better. Okay, na? One second. Xeno diode. It is also easy and important. You can follow any order. Xeno diode, varicap diode. These two. ఈ 5 types లో నుంచి ఏదో ఒకటి 5 marks ఎక్స్పెక్ట్ చేయొచ్చు. ఒకవేళ బై ఛాన్స్ గా వస్తే 10 marks లో పిఎన్ జంక్షన్ డయోడ్ వర్కింగ్ అడగొచ్చు, లేదంటే నెక్స్ట్ టాపిక్ ఉంది ఇంకోటి ట్రాన్సిస్టర్ది, దాంట్లోనే అడగొచ్చు. మాక్సిమం ప్రాబిలిటీ, మాక్సిమం పాసిబుల్ ఏమో ట్రాన్సిస్టర్ లో ఎల్ఏక్యూ, డయోడ్ లో ఎస్ఏక్యూ అడగొచ్చు. ఒకవేళ బై ఛాన్స్ గా అడిగితే దీంట్లోనే 10 marks అడగొచ్చు. నెక్స్ట్ అప్లికేషన్ ఈజ్ జీనా డయోడ్, స్పెషల్ డయోడ్. ఆల్ ఆర్ స్పెషల్ డయోడ్స్. వన్ జీనా డయోడ్, a heavily doped PN junction diode in reverse bias. Heavily doped PN junction diode in reverse bias. It can works always in reverse bias only. It can works always in reverse bias. So what about in forward bias, sir? In forward bias, it can behaves like an ordinary PN junction diode. Next point. It is used as a voltage regulator. It is used as a voltage regulator or power supply voltage regulators. Okay na? Zener diode, always it can works in the reverse bias. It is used as a voltage regulator. Next is Zener diode circuit symbol. CKT, circuit symbol. పిఎన్ జంక్షన్ డయోడ్ లాగే ఉంటుంది కానీ ఇక్కడ జెడ్ సింబల్ వస్తుంది. సమ్ టైమ్ ఇలా సర్కిల్ కూడా చేస్తాడయ్యా, అదైనా సేమ్ మీనింగే, సర్కిల్ ఉన్నా లేక ఉన్నా నో ప్రాబ్లం. అలా ఉన్నా ఓకే, సమ్ టైమ్ థింకింగ్ డైరెక్ట్లీ ఇస్తాడు. అంటే ఇది పి రీజన్ ఆల్వేస్, ఇది ఎన్ రీజన్, లేదంటే ఇలా కూడా ఇవ్వచ్చు. ఆ సర్కిల్ మోస్ట్గా ఏంటంటే లైట్ ఇన్సిడెంట్ దానికి, లైట్ ఎమిటింగ్ దానికి సర్కిల్ ఇస్తాడు మాక్సిమం కేసుతో. అంటే ఫోటో డయోడ్ కి కానీ ఎల్ఈడికి కానీ అవి ఇన్సిడెంట్ ఎమిషన్ కదా, వాటికి ఇస్తాడు. ఈ పిఎన్ జంక్షన్ డయోడ్ కి, జీనా డయోడ్ కి, వీటికి ఈ సర్కిల్ సింబల్ ఉండదు మోస్ట్ ఆఫ్ ద కేసెస్ లో. అంటే సర్కిల్ లైట్ ఇన్సిడెంట్ అవుతుంది కాబట్టి అక్కడ సర్కిల్ పెడతాడు, లేదా లైట్ ఎమిటింగ్ కండిషన్ లో సర్కిల్ పెడతాడు బల్బ్ లాగా. ఓకేనా? ఏం చెప్పాం? Zener diode, Zener diode means heavily doped PN junction diode in reverse bias is called as Zener diode. It can works always in reverse bias. In forward bias, it can behaves like an ordinary PN junction diode. It is used as a voltage regulator. The circuit symbol of PN junction diode is that thing story only. Okay. Now we can take for example one circuit diagram used as a voltage regulator purpose. Voltage regulating purpose, input resistance, and then you can connect here is a Zener diode. Zener diode. Zener diode. Okay, it is a negative, it is a positive. P negative terminal connected to P region, positive connected to N region. This is a input current, that load resistance. Here V in, this is a V out. This is a voltage across the Zener diode VZ. Input current I in, this goes on I in. At this junction, current it can splitting according to Kirchhoff first law, current law. Entering current is equal leaving current type. So current across the load resistance is a IL. Current across the input Zener diode is called as a IZ. Current across the Zener diode is called as a IZ. Okay, na? So input current In is equal to IZ plus IL. IZ plus IL at the junction. Sometimes they'll ask least current across the Zener diode or maximum current across the Zener diode purpose. In terms of voltage, you can apply this is one closed loop. In this closed loop, we can take it as delta V is equal to I in into R in. The delta V value you can take it as input voltage minus VZ. V in minus VZ is equal to I in into R in. For example, they will apply input voltage range 80 to 120 volt. 80 to 120 volt. Here 50 volt across the Zener diode. For example, here 50. 50 voltage across the Zener diode. VZ is equal, for example, 50 I'm feeling. Then they'll ask how much minimum current flows through the Zener diode, how much maximum current flows through the Zener diode. So here minimum condition purpose, minimum voltage, maximum current purpose, maximum voltage range. 80 minus 50, then we'll get here 30 is equal to I in R in. R in value they can give. Maybe that is a 5 kilo ohm resistor or whatever, different values. Based on that only you can calculate I in. Based on that I in you can calculate IL and IZ. So here VZ is 50 volt means automatically these both are in the parallel component conditions, voltage remain constant, V out also will get 50 only. So from that voltage 50 you can calculate IL value. V is equal to IR. So they can give here high value maybe 10 kilo ohm, 2 kilo ohm, 1 whatever with given values. Based on that given values you can find out here IL. If you get IL something, I in something, automatically IZ also will get based on this equation. IZ is equal to I in minus IL. Then we'll get minimum current. Similarly, we'll get maximum current. This is a Zener diode used as a voltage regulator purpose. But they won't give sometime maximum cases values. They'll ask connection and explanation part. How they are using Zener diode used as a voltage regulator circuit diagram draw. Just 5 mark purpose. Just you can draw the only diagram of thing on. Note on this point. And then next we can take the IV characteristics of Zener diode. This voltage current graph I'm drawing here. So voltage values on x-axis, current values on y-axis. Current here milliampere in this axis, current measure in terms of microampere. Here voltage V on. We know Zener diode in forward bias, it behaves like a ordinary PN junction diode. Then similar to the PN junction diode characteristic graph only in forward bias. In reverse bias, sir, when you are applying heavily doped diode in the spinner, that is my bad. In reverse bias, Zener diode up to certain voltage is zero only. After that, suddenly it can break down. This breakdown voltage is called as a Zener voltage, Zener breakdown voltage. This corresponding voltage. Zener break down voltage. So previous condition ఏంటి ప్రీవియస్ కండిషన్ లో పిఎన్ జంక్షన్ డయోడ్ ఏమైంది ఎక్స్పోనెన్షియల్ గా డిక్రీజ్ అయింది కర్వ్ వచ్చింది ఇక్కడ కరువు రాదు, స్ట్రైట్ గా పడిపోతుంది, అప్పుడు కట్ అవుతుంది. In the forward bias, it can behaves like a same like a PN junction diode laga. In the reverse bias, it can suddenly break down the voltage. In the reverse bias, it can suddenly break down the voltage. That voltage is called as a Zener breakdown voltage. That voltage is called as Zener breakdown voltage. Okay, na? Note it down. This is a Zener diode. Next one more is varicap. ఇది కూడా రిపీట్ అయింది, 2-3 times రిపీట్ అయింది ఎగ్జామ్ లో, 5 marks లో. First note down this point, then we can go to varicap diode. That thing you can go through it in your material, page number 14. Varicap or varactor diode, VVC, voltage variable capacitance, another name. Voltage variable capacitance diode. You can say in another way, varicap diode name. Voltage dependent variable capacitors. Their mode of operation depends on the capacitance that exists at the PN junction.
Sir, excuse
That
me, sir.
exists. Yes.
Sir, please tell us the important topic names of block 2, 3, 4, sir. Why? Because I skipped the top block number 1.
Hmm.
In the exam point of view, what are the important topics of block 2 and 3 and 4, sir?
Block 2, block 3, block 4, even though block 1 also I shared last time important questions along with the page numbers also. One second, I once again I share that important question. I was written on the board the page number, question number, chapter wise, like unit wise. That question once again I'm sending. You can see everyone. If still you have any doubts in that one, I will explain it. Just a second. Where to go? This group app.
Sir, block 3 multiplexer topic, sir, that is somewhat difficult. So, will you explain it in next class or?
Okay. Why? Because block 3, block 4, block 2, I explained the online mode. Few students came, few students are absent due to some other reasons. And now I'm coming back to first block. After finishing up these, we'll go to continuously required things. ఎందుకంటే ఏది క్లారిటీ లేకుండా అవుతుంది మీ ఇద్దరి మధ్యలో అనేసి, ఒక్కొక్క యూనిట్ కంటిన్యూగా వెళ్ళిపోతే ఇట్ విల్ బి బెటర్.
I'm attending today only the class.
Oh, such kind of problems, how can I solve this thing?
Actually, we don't know. Sir, మాకు తెలీదు సార్ మీరు ఆన్లైన్ క్లాస్ ఇలా కండక్ట్ చేస్తున్నారని చెప్పి కూడా ఈ రోజు నాకు
That's why
మెసేజ్
I'm
రావడం.
telling one more opportunity I'm giving here. Officially from the university side, today and tomorrow is the last session of the online classes. So in official, these all the classes are recording only. After finishing of today and tomorrow class, how much syllabus is possible, that much syllabus in the first block again I'm revising. After finishing up that, I will take extra, that is not recorded classes, in the evening hours, late evening hours in the working days. I can plan in the working days, evening hours.
Okay.
That will better only now. Like
Sir,
yourself types, few students, those who are delayed in the classes, such kind of students, you can intimate me which topic you want, which
sir,
topic you want, that topic you can let me know, that topic I will explain.
ఓకే. మీరు లింక్ మరి మాకు పాస్‌కోడ్ ఇవన్నీ కూడా వాట్సాప్
Yeah,
గ్రూప్‌లో
yeah.
ఇంటి
I'll share in the group only. I'll share in the group only. If possible, we can continue this link, this group only. Otherwise, I have private Zoom app. That 45 minutes class fee of cost is there now. That link we can share in the group.
ఓకే. ఓకే
That
సార్.
possibility also. Why? Because online mode only na, that is the extra purpose. So here officially they are giving time total 10 classes in online mode only. 1.5 hour classes, 10 classes in the online mode. The schedule is going to finishing up tomorrow only. After finishing
మోస్ట్‌లీ
up that schedule, again, if you want, not a forcible for everyone, those you want, that students you can message to myself or in the group, we can plan extra only.
సార్ మోస్ట్‌లీ బ్లాక్ 3 లోనే డౌట్స్ ఉన్నాయి సార్. ఎందుకంటే ఎగ్జామ్ పాయింట్
అదే
ఆఫ్
అదే
వ్యూలో
అంటున్నా కదా,
బ్లాక్
ఎందుకంటే
2 అండ్
ఇప్పుడు
4
నువ్వు బ్లాక్ 1 అడిగావు, ఇప్పుడు ఈ క్లాస్ ని ఇక్కడ హోల్డ్ పెట్టి నేను బ్లాక్ 1 బ్లాక్ 3కి వెళ్ళిపోయాను అనుకో, క్లారిటీ ఉండదు. ఇంకో స్టూడెంట్ వచ్చేసి నేను బ్లాక్ 1 మిస్ అయ్యాను అంటాడు. అంటే నేనేం చేస్తున్నాను, నా వేలో ఒక ఆర్డర్ లో టీచ్ చేసుకుంటూ వెళ్ళిపోయాను. ఈ బ్లాక్ 1 ఆఫ్లైన్ లో చెప్పాను, ఆన్లైన్ లో బ్లాక్ 2 బ్లాక్ 3 బ్లాక్ 4 ఆన్లైన్ లో టీచ్ చేశాను. ఈ బ్లాక్ 1 ఆఫ్లైన్ లో అయింది కూడా మళ్ళీ ఇప్పుడు కవర్ చేస్తున్నాను నేను. అంటే నా టీచింగ్ కొద్దిగా స్పీడ్ గా చేసి ఇక్కడ టైం రిడ్యూస్ చేసుకొని టైం సేవ్ చేసుకొని ఈ టైంలో బ్లాక్ 1 ని కవర్ చేస్తున్నాను.
ఓకే సార్. ఓకే సార్. థ్యాంక్ యూ సార్.
అలా నెక్స్ట్ సో అందుకే ఇది అయిపోయాక ఒకవేళ ఇఫ్ రిక్వైర్డ్ ఫర్ ఎనీ వన్ ఇన్ దిస్ గ్రూప్, ఆబ్వియస్లీ వీ హ్యావ్ సో మచ్ టైమ్ దట్ ఎగ్జామ్స్ ఆర్ ఎక్స్టెండెడ్ టు ఐ థింక్ సెప్టెంబర్,
సెప్టెంబర్
ఐ థింక్
20థ్
September
సెప్టెంబర్
20 onwards,
20
huh? Yeah, yeah.
2021
So
2023.
yeah, so we have time now. So in these gaps, based on your comfortable time, my comfortable time, we can plan in the evening hours or any holidays conditions. That thing we
ఓకే.
can
థ్యాంక్ యూ.
communicate in the WhatsApp group or personal numbers. So based on your requirement, I'll teach in online mode only. That is
ఓకే సార్.
extra.
ఓకే.
But now I won't break up these schedules.
ఓకే.
Okay, no? Right.
ఓకే సార్. థ్యాంక్ యూ.
Someone send one place mobile the message. You can explain Zinodioid in Telugu if possible. తెలుగులో వర్డ్స్ ఎక్స్ప్లెయిన్ చేయలేము సార్, కాకపోతే కానీ మాటలు అయితే ఇవన్నీ చెప్తాం, కానీ టర్మినాలజీ జినాడైడ్ నే కానీ తెలుగులో ఏదో ఉంటుంది. ఐ డోంట్ ఐడియా ఇన్ ద తెలుగు. వన్ సెకండ్ ఐల్ గివ్ ద పాయింట్స్. వన్ ప్లేస్ మొబైల్, ఐ డోంట్ హ్యావ్ వన్ సెకండ్. Sir, can you please explain again about Zinodiode if possible in Telugu? If previous classes recorded, please send videos, sir. ప్రీవియస్ క్లాస్ రికార్డెడ్ మా దగ్గర ఉంటాము, యూనివర్సిటీ బోర్డు వాళ్ళ దగ్గర ఉంటాను. ఇప్పుడు దీనిలో గ్రూప్ లో బిఆర్యు హెచ్ఓడి ఉంది కదా, వాళ్ళు రికార్డెడ్ పర్సన్ అనేసి పోస్ట్. ఓకే రైట్, కమ్ బ్యాక్. Xena diode. Once again repeating point here. Xena diode. A heavily doped PN junction diode in reverse bias. A heavily doped PN junction diode in reverse bias is called as a Xena diode. It can works in reverse bias. One second. Yeah. Heavily doped PN junction diode in reverse bias is called as a Xena diode. It can works always in reverse bias. In forward bias, it can behave like a ordinary PN junction diode. In forward bias, it can behave like a ordinary PN junction diode. It is used as a voltage regulator. The circuit symbol of Xena diode is same similar to the PN junction diode, but instead of line, it can షేప్ ఈజ్ ఏ జెడ్ సింబల్ టైప్, జీనార్ నా జెడ్ సింబల్. పిఎన్ జంక్షన్ డయోడ్ కి జస్ట్ ఓన్లీ లైన్ వస్తుంది, ఇక్కడ జెడ్ సింబల్ వస్తుంది. దిస్ ఏ పిఎన్ జంక్షన్ సారీ జీనార్ డయోడ్ సర్క్యూట్ సింబల్. And Zener diode used as a voltage regulator, we are saying na, that circuit diagram we can observe here. This explanation part not necessary. One input resistance in series with the terminals of Zener diode, negative and positive things. Positive region connected to N and negative region connected to positive. And one more load resistance connected to the Zener diode in the parallel. These two components are parallel, now voltage remain constant. So it means here voltage of Zener diode, voltage of load resistance same only. This is a R in input resistance. This is a input current. At this junction, we can apply Kirchhoff first law. Sum of current entering to the junction is equal sum of current leaving to the junction. That is a IZ plus IR. Extra numerical problem here they will ask very rare cases current across the Zener diode, minimum current to maximum current purpose. That is a very rare case they can ask. Just they can ask the diagram part. After that, IV characteristics of the Zener diode. Zener diode voltage value on x-axis, current value on y-axis. In the forward bias, we said it can be as like a PN junction diode type na. That's why here is a same like a PN junction diode curve type only. Next, in the reverse bias, the voltage suddenly it can break or it can drop. At what voltage the current is suddenly break, corresponding that voltage you can say Zener voltage. That voltage you can say Zener voltage. Okay na? That is it. That is a Zener breakdown voltage or Zener voltage. That's it. This is about the story about the Zener diodes. And a 5 marks purpose. Minimum 5 to 8 points. ఇక్కడే 5 points ఉన్నాయి, ఇది explanation diagram ఉంది, ఆ graph ఉంది, obviously will get easily 5 marks. Similarly, next one is a varicap or varactor diode or VVC diode. Voltage variable capacitance diode. Voltage variable capacitance diode. Okay na? This is a VVC part. That is a theoretical part is there. That part you can go from textbook page number 14. VVC is called as a voltage variable capacitance diode. As semiconductor materials, it depends on voltage dependent and capacitor values dependent. Their mode of operation depends on the capacitance that exists at the PN junction when the element is reverse bias. Under reverse bias condition, it was established that there is a region of uncovered charge on either side of junction that together make up the depletion region and define a PN junction diode with WD. First we'll rub this part. Next we can go to the varicap. Next we can go varicap. The symbol of varicap, first we can take it as this is a PN junction diode na. Thing is here like this cap, varicap. అంటే డయోడ్ కి లైక్ డైరెక్ట్లీ కనెక్షన్ చేస్తుంటే ఇది పిఎన్ జంక్షన్ డయోడ్, ఇక్కడే ఉంది ఇలా కనెక్షన్ ఉంది. దిస్ ఏ varicap diode or VVC, voltage variable capacitance. దిస్ ఏ కెపాసిటెన్స్ సింబల్. కెపాసిటెన్స్ సింబల్ ఇలా ఉంటుందో దానికి ప్లేట్ ని కెపాసిటర్ ప్లేట్స్ ని కొద్దిగా క్రాస్ పెట్టడం. డయోడ్ దగ్గర స్ట్రేట్ లైన్, జీనో డయోడ్ దగ్గర జెడ్ సింబల్, varicap దగ్గరనేమో ఇలా సి. యా, ఇక్కడ ఏమన్నాడు ద ఎక్స్ప్లెనేషన్ పార్ట్. It exists at the PN junction when the element is reverse bias under reverse bias condition. It was established that there is a region of uncovered charge on either side of the depletion layer junctions. This is nothing but PN junction, nothing but this is only PN junction diode. No? This is the depletion layer, P region, N region. P region contains positive charge carriers, N region contains negative charge carrier ions. And according to the sentence, it was established that there is a region of uncovered charge on either side. అంటే దీనికి ఇదివరకు ఏమైంది ఇక్కడ when it is connected in the forward bias or reverse bias across the depletion layer ions వచ్చి ఇక్కడ పాజిటివ్ ions depletion layer ఈ edge కి నెగిటివ్ ions ఈ edge కి ఉన్నాయి. But it won't stay here in varicap diode. Either side of depletion layers, it was established that there is a region of uncovered charge on either side of the junction that together make up the depletion region and define the depletion width. The layer of the width is, the depletion layer width is a WD. This is a depletion layer width. The transist capacitance, ఇక స్టేబుల్ అవ్వకుండా డైరెక్ట్ ఇక్కడ నుంచి ఇక్కడికి జంప్ అవడానికి ఏవి పాజిటివ్ అయాన్స్, నెగిటివ్ అయాన్స్ ఇక్కడ నుంచి ఇక్కడికి జంప్ అవడానికి. దట్ ఈస్ రిక్వైర్డ్ థింగ్ ఈజ్ ఏ ట్రాన్సిషన్ కెపాసిటెన్స్. సిటీ అంటే ఇక్కడ మిడిల్లో హోల్డ్ అవ్వకుండా డైరెక్ట్ ఇక్కడ నుంచి ఇక్కడ జంప్ అవడానికి పాసిబిలిటీ. ఇట్ కెన్ వర్క్స్ ఇన్ ద రివర్స్ బయాస్ కండిషన్ చెప్పాడు కదా వాడు. ఇట్ కెన్ the transition capacitance CT established by the isolated uncovered charge is defined by, and charge defined by I think we know capacitor, capacitance, parallel plate capacitor, capacity in the previous thing. What we can say in either intermediate standard. Parallel plate capacitor capacity C is equal to epsilon naught A by D. So same like here. Here field intensity is a E, either V. Instead of epsilon naught, you can take it as C is equal to E into A. Here width is a depletion layer width, that is a VD. This formula we can go through it in the textbook. C is equal to EA by WD. This is a transition capacitance. It was CT. Transition capacitance. A transition capacitance of charge carriers. CT is equal to EA by WD. Uncovered charge is determined by E is a electric field or external field, A is a area of cross section, WD is a width of the depletion layer. Or else it can be written as, instead of E, you can take it as this thing also. It can be written as CT is equal to epsilon naught A by WD or D also directly. You can mention that is a permittivity of a free space of semiconductor materials, and next WD is a width of the depletion layers. WD is a width of the depletion layers. Okay, na? A is a area of cross section of the plate. The terminal is given. As the reverse bias potential increases, the width of the depletion region increases, which in turn reduce the transition capacitance. The characteristics of a typical commercially available varicap diode shown in the figure. Varicap diode symbols. Okay, na? That's it. This much part is enough for varicap diode. Okay. Okay, na? That's it. Like this, you can go through it in these unit questions. Types of diodes, and next one, PN junction diode application things. It's my bad. PN junction diode working in forward bias, in reverse bias thing on. Right? Then next, tomorrow class, we can discuss about the transistor part. Transistor part we can discuss in tomorrow same time. We'll try to cover transistor part in tomorrow. After that, if required, anybody you can inform me based on your convenient time, my convenient time. We can adjust the extra class. We can try to discuss doubtful topics, or else which topics you are missed. The topics we can plan later. Now I'm stopping this class here only.
Excuse,
And
excuse, excuse me, sir. If
yes, tell
it
me.
is possible, can we discuss fourth block tomorrow? Because there is two lessons is there and
Better according to schedule, we have to finish. Why? Because in the online mode, how we can teach two chapters together? Sorry, same chapter two times. That's the issue problem. So better we'll try to finish tomorrow class this thing only, new topic. Then we can go to next class. After tomorrow next class, anytime we can go through it fourth block based on your comfortable.
okay, sir. Thank you.
Okay, is it okay? Next, is there any queries from your side? Any suggestions? Oh, again for Mrs. Sarkin. Ah, it's okay. Thank you, Mrs. Only. Okay,
Sir,
right.
excuse me, sir.
Yes, tell me.
Sir, is there any possible to an offline classes? Because already
Offline classes, already 5 classes are done.
yes, sir.
Yeah, remaining 10 classes, they are planning in the offline mode only. Sorry, online mode
Yes,
only.
sir. Yes, sir.
Offline.
Already, I mean, offline is better than online. So that if it is possible,
Hmm.
if it is possible, that's it. As a request.
ఆఫ్లైన్ మోస్ట్లీ పెట్టకపోవచ్చు. ఏదైనా డౌట్ ఉంటే యూనివర్సిటీలో ఉన్న ఫ్యాకల్టీకి వెళ్ళి అడగొచ్చు. లేదంటే సబ్జెక్ట్ కన్సల్ట్ ఫ్యాకల్టీని అడగొచ్చు. కానీ అఫీషియల్గా అయితే దే వోంట్ కండక్ట్ ఎనీ ఆఫ్లైన్ క్లాసెస్ ఫర్ దిస్ అకాడమిక్ ఇయర్.
Thank you.
ఇంకేదైనా డౌట్ ఉంటే నియర్ బైగా హైదరాబాద్ లో ఉన్న వాళ్ళు కానీ, లేదంటే ఆల్ ద మోస్ట్ ఆఫ్ ద ఫ్యాకల్టీ దే కెన్ స్టే ఇన్ ద హైదరాబాద్ ఓన్లీ. ఆల్ 4 faculties, paper 1, paper 2, paper 3, paper 4, they can stay in Hyderabad only. If any doubts, if in case of you are nearby in Hyderabad areas, you can directly contact the faculties, you can approach, but I'm not sure that faculty is interested offline. In online already they are teaching here only enough. If any require from your side, you can request to the subject faculties, you can take extra classes. That is the second opportunity.
Thank you so much.
Okay, right. Okay, thank you. I'm also stopping here only meeting. Bye.
Thank you, sir.
Okay, we'll meet tomorrow same.